Yeah, thank you for the introduction. We are very excited to be here. There has been some very interesting talks at this conference. So I'm happy that you join us here for our session when we explain you and talk a little bit about our challenges implementing multi-tenant solutions with OpenSearch for Kubernetes. So I want to start to tell you a little bit about our journey with OpenSearch. I want to dive into some aspects regarding platform engineering. We will tell you about how we integrated Kubernetes and OpenSearch for our logging workloads, how we streamlined our customer and tenant onboarding, and we want to wrap it up with some limitations, talking about some limitations, and tell you our lessons learned regarding this topic. So we started our OpenSearch journey back in 2015. We work at RISE, which stands for Research Industrial Systems Engineering. We're an Austrian-based IT company. We operate in whole Central Europe with branch offices in Berlin or in Bern in Switzerland. And we are specialized in implementing large-scale systems in the finance, e-health, and public sector. And since we have a strong background with the Technical University of Vienna, we are originated from the Technical University. We have a strong background in research and IT security. And we started 2015 with Elasticsearch. Back then, some of you might remember, node names were already were still named after Marvel characters, so it was that early. And we were implementing a customer project with a company in the Austrian public sector, where we migrated legacy applications written in COBOL and PL1. That originally run on a mainframe, on an IBM mainframe, and we migrated them to a TX series platform. And we used an ELK stack at this time to parse all this legacy application log data, where the applications were kind of ancient. They were written in the 70s or 80s, and we parsed that data into an Elastic Stack, and out of that we built a monitoring tool, a monitoring solution for the operations team that they could use. And actually, the monitoring tools that were used at the mainframe were like looking like this. It was like a terminal application, and then we replaced it with a nice workingly user interface. And in 2021, we then moved from Elasticsearch to OpenSearch, primarily because we, as a solution provider, wanted to offer a managed service solution, and we wanted to be independent from any commercial vendor or licensing model. From this early project, we expanded our service offering within our company. So we started with automation. Other projects came to us and said, hey, we heard about this one project. We basically need the same. We need log analytics for our application. So we added more environments. We added more clusters. After that, there was like a phase of growth where log analytics kind of took off. So we built a dedicated team within our company for log analytics. And we started to build our OpenSearch platform. We also started with security monitoring. We implemented our own security monitoring solution, which led to the last phase, the productification phase. We reached a grade of maturity in our solution that allowed us to enter the open market. So we thought about product branding, solution branding. Our solution is named LOMOC, which stands for Log Monitoring Operation Center. And we were thinking about standardizing some of our processes regarding customer support and training. Coming to the present and looking back, through our journey, we had a lot of growing pains. And if I have to boil it down to just one slide, which of course is a major abstraction, but I would boil it down to one point, and the point is be aware of creeping heterogeneity. So this is where a system over time gradually becomes more complex than you originally intended to. So the antidote for to treat heterogeneity in a system is standardization. So you can use standardization in different spaces, in different areas, to contain heterogeneity. For example, the most obvious space you probably doing is the automation space. So you can automate relevant aspects of OpenSearch, like configuration management, cluster setup, to implement a specific way to doing a specific task. And this enables you to keep things consistent over tenants and environments. In the requirement space, you can use conventions with your users, for example, for retention policies, index naming, or you can enforce or recommend structured logging standards to your users to make things simpler. We also provide our users with a default set of dashboards, so they can have a start with a predefined dashboard, and they don't start with an empty OpenSearch dashboards instance. And in the final space, in the operational space, one of our biggest issues was that we had unclear rules about when and how to separate tenants. So in the beginning, it was kind of messy. Then we had to do a lot of migration work to keep it more consistency. In fact, about this topic, I want to tell you a little bit more details in just a second. When we built our OpenSearch platform, at first we were concentrated, of course, on the technology, delivering OpenSearch as a technology to our users. It was like this. We said, here's your cluster. Now we're finished. Have fun with it. For some teams, that was OK. They liked it. But most of the teams really struggled with this approach because they were new to the technology. They didn't know how quite to use it. And basically, they needed more than just the technology. They needed guidance on how to get the insights they needed from the log data out of the system. So we realized we have to do more than just providing technology. And we thought of two areas. One area was reusable building blocks. So we want to use standardized building blocks, for example, dashboards or log parsing that made our lives easier. And we wanted to hide the internals, abstract the internals of OpenSearch from the user. So the user shouldn't have to think about dynamic sharding strategies, as we heard before, or other internals like retention policies or cluster configuration. So we want to abstract that complexity from them. The user should concentrate on knowing their data and getting insights from their data. So what we're trying to do is moving from a technology provider, technology as a service provider, more to an operational value as a service provider to our users. While expanding our platform to more and more environments, and coming back to the point of cluster separation with this, we encountered ourselves with a diverse set of operational and technical requirements. And these requirements were kind of pulling us apart. For example, there was we had applications. They had different workload types. So they had different operational needs for ingest rate, for example. So some of the applications were fine when ingesting is a little bit slower sometimes, and some other applications broke completely if the ingest delay was a little bit higher. And on the other side, we had applications and projects where they had a high need for service level agreements. They had very strict service level agreements we had to comply with, or specific maintenance windows that we had to comply with. So also these tenants were very particular. So we had this set of requirements, and what we did is we created a decision strategy I want to share with you, where we decided when and how to separate tenants and when to not separate tenants. So the decision strategy works like this. We have 3 layers of separation. We have a data center separation, an infrastructure separation, and a tenant separation. And at the top, we have one dogma or one mantra, as you can call it. We want to ensure data center locality. So we want to prevent log data flowing from one data center to another. An application that logs the data should all reside in an OpenSearch cluster that runs in the same data center. So out of that, we divide between 2 types of OpenSearch cluster, 2 types of data. So the first one is the basic log cluster you can imagine, and the other one is, as we call it, a record store. That's OpenSearch cluster for applications that connect directly to OpenSearch and using it as a ingest and search database backend. We separate these 2 because they have different requirements regarding stability. So within the log cluster, we also separate between infrastructure clusters and application clusters, because infrastructure clusters hold sensitive data that are required for security monitoring. And our security team had the requirement that it has to lie on a separate infrastructure. So the infrastructure cluster holds sensitive data where the application cluster doesn't hold sensitive data like audit logs. So, and then we have 2 types of OpenSearch cluster, which is a multi-tenant cluster and a single-tenant cluster. So with the multi-tenant cluster, we use the tenant features in OpenSearch to separate tenants. And the single-tenant cluster is, as the name says, it's just one cluster for one tenant. We do single-tenant clusters only if it's reasonable, only if there is a specific reason to do so. For example, scalability needs, high performance needs, and so on. So this is the strategy we use. I encourage you, if you have the same problem, if you are on the same journey as we are, that you think about something like this, something similar. In our experience, it will save you time down the road. But multi-tenancy is not only on the OpenSearch side. You have to think about also about the client side. So I want to give you a short introduction how the Kubernetes architecture works. So on the Kubernetes side, we of course have different Kubernetes clusters. We separate them in stages, and each tenant can have multiple namespaces on multiple of those clusters. We use LDAP groups for access control. The LDAP group defines to which for each tenant to which namespace it has access to and on which namespace he can deploy. And we heavily rely on Argo CD that makes the deployments. So what happens with the logs actually from those workloads? So per default, they all go on standard out to the logging subsystem of Kubernetes. And yeah, how can you watch that logs? Of course, you can log in with kubectl and look at the logs like the old-fashioned way. But of course, you don't want to do that this way. You want to have a centralized storage with OpenSearch. And this is where I pass over to Maximilian, who will tell you more about how we integrate Kubernetes and OpenSearch.
Thank you, David. So now let's have a look how we can connect Kubernetes and OpenSearch. So the first thing we should probably do is some requirements engineering to avoid chaos later on. And basically from an operational point of view, the most important question is how can we get the logs from Kubernetes into OpenSearch? We also want to reduce our overhead, as David already mentioned. And for that purpose, we need to create some standardizations regarding index naming, log parsing, ISM policies, and so on. Then we also need to take care of access management. We only want authorized users to access their logs. And we also need to make sure that tenants don't go over their storage capacities. From a user's perspective, users want to have a unified and tenant-scoped entry point. That means that upon selecting a tenant, the users can only see the logs relevant to this particular tenant. They also need to have some type of pre-built dashboards to make sense of their logs, and they need the ability to raise special requests regarding log parsing, ISM policies, and any custom dashboards they may need. So as you can see, we have a conflict of interests here, because from our point of view, we want to standardize as much as possible. But at the same time, we want to enable our customers to be able to raise special requests. So our mantra is standardizations where possible and useful heterogeneity when necessary. So now let's have a look at log shipping. So on the Kubernetes side, we are using the Kubernetes logging operator. And the Kubernetes logging operator works with things called log flows. So essentially, we have one log flow for every single tenant namespace. And the log flow basically just matches the logs from all the pods within the namespace. And it then forwards those logs via HTTP to Logstash. The reason why we are using Logstash is primarily because we have a lot of experience with it, and it has worked quite well for us in the past. You can also see that there is one global log flow for the Ingress logs, and this is global because the Ingress controller resides in a global namespace, the kubesystem namespace. So you also see that I've highlighted some text here for the record transformer, and we'll get to this later because this is really important in our setup. But let's talk about standardization for a little bit now. So when we talk about standardization, we just mean a set of common rules and patterns that is applied across all OpenSearch environments and clusters to ensure a consistent structure, behavior, and configuration across all the logging components. So why are we doing this? So first and foremost, as I already mentioned, we want to reduce our operational overhead by avoiding case-by-case configurations. Imagine if you have to think about index naming, Logstash pipelines, ISM policies. Every time you have to onboard a new tenant, it will just give you a massive headache. So not only does standardization simplify the process of onboarding new tenants, but it also enables us to automate most of it. And now let's have a look at index naming standardization as the first example. So imagine you have an index, which is basically just called whatever its log type is. So K8s or Kubernetes for the Kubernetes logs. Now, it's quite obvious that we are limited here in regards to ISM policies. So let's add a date pattern to this index. Now with the date pattern, we can define ISM policies to delete our indices based to our likings. But now imagine we have a cluster with 2 tenants, and tenant 1 wants to delete indices after 30 days, and tenant 2 wants to delete indices after 60 days. This won't work currently, so we'll add a tenant to the index name. Now we've added the tenant, and now imagine that tenant 1 comes along and wants to keep the logs from one certain Kubernetes cluster for a longer period of time than the logs from another Kubernetes cluster. Again, this won't work for the same reasons as before. So let's add the Kubernetes cluster. Now, what we found in the past is that we also need some kind of extra attribute for customizations. So imagine if tenant 1 now comes along and has a really important application pod, and the logs from this pod need to be retained a lot longer than all the other logs. Right now, we can't really do that because we have no way of telling by the index name that the index contains some special logs. So what we've done is we've added a lifespan attribute for customizations based on customer requests. This lifespan attribute can either be set to default, which means that the default settings, like the default ISM policies, will be applied to that index, or it could be set to archive, which tells us that this index must be retained for a longer period of time. Now, you need to be cautious with index naming a little bit. So, for example, if you decide to use the Kubernetes namespace as part of your index and combine this with a daily date pattern, you might accidentally create a lot of very small indices. So to avoid this, you could use a different date pattern, for example, and this will make sure that you will receive enough logs from this one particular Kubernetes namespace. Now, really, to just go back to this slide, the key idea is, or the key takeaway message for you should be that you really have to think about index naming before all else, since it's like the backbone for everything that follows now. Now, we've established from the index naming that we need to have a log type, a tenant, and a cluster within our index pattern. And before I withheld some information from you regarding the record transformer. So essentially, all the record transformer does, it adds some information to every single log line. So now if we add this information, the log type, the tenant, and the cluster, to every single log line, it will then be sent to Logstash, and then Logstash can use this information to create the indices like we have specified them right before. So now let's have a look at Logstash. So the general problem with Logstash or log parsing is that you will encounter many different logging formats. So you might have unstructured logs, like plain text, or structured logs, like JSON or XML. So even though the Kubernetes logging operator is sending all the logs in JSON, the actual message or the actual log message originating from the container could be plain text, it could be JSON, it could be XML, or anything else. So really you end up with something that's XML in JSON, plain text in JSON, JSON in JSON. And so the challenge now is that the attempt of trying to standardize log parsing kind of conflicts with real-world log formats. To tackle this problem, we came up with a modular Logstash architecture, which basically just has one input pipeline at the very top to receive all the logs from the Kubernetes operator. Within this input pipeline, we separate the logs by the log type. If we're dealing with ingress logs, we know that we will have a predefined format. So one ingress pipeline will suffice to do all the parsing for us. If we're dealing with Kubernetes logs, we know that the logs originate from tenant applications. So at this point, we still don't really know what the log parsing is going to be like. So for this purpose, we have one default tenant pipeline, which just does the basic parsing, like JSON and JSON parsing, for example. If a tenant needs some special parsing and this default tenant pipeline isn't enough, then we have some tenant-specific pipelines. So whenever a tenant comes to us and says, this basic parsing won't work for me, then we can just add a new tenant pipeline for this particular tenant. So once all the logs are parsed, they then travel to the output pipeline. And in the output pipeline, the logs are then sent to OpenSearch using the indices that we've mentioned before, containing the tenant, the cluster, and so on. And here is a really good example why you should really carefully think about your index naming, ISM policies. So when we are trying to standardize ISM policies, the key idea is just to provide a default set of policies that will work for most cases. So let's have a look at the retention policies in this table, for example. So at the very top, you can see one catch-all base policy, which will delete indices that are named like this after 14 days. Further below, you can see multiple tenant-specific policies. So for example, the second one would delete all the indices for tenant 1 after 30 days. And then you can go even one level deeper, and you could say that tenant 1 might want to delete all the indices from the prod Kubernetes cluster after 45 days. So really, the key ingredient to this is carefully planned index naming. Now, how do we onboard our customers, and how do we automate this? So at the heart of our Kubernetes integration lies the OpenSearch sync data, which is a custom resource definition for Kubernetes that we've created. There's exactly one OpenSearch sync data to describe one tenant namespace. Now let's have a look what this OpenSearch sync data looks like. So here in the spec, you can see the most important bits. At the top, we have a cluster name, we have LDAP groups, we have a namespace and a project name, which is equivalent to the tenant name. So out of this information, we can first of all recreate the index that will be created by Logstash later on. Then we can also create a role and a role mapping that allows only the users from this particular LDAP group to access the logs on the index that is created by Logstash. So really, as you can see, this is like the heart of our access management, and it can be easily automated, so you can set up the roles and all the role mappings, and we'll get to that later on. At the bottom, you can also see this setup finished boolean, which is currently set to false. And once this is set to true, the Kubernetes logging operator will start the log flow and the ingestion will happen. I also briefly talked about default dashboards, and default dashboards are just a great way to visualize information for your tenants. So we've done some ingress log dashboards and container overview dashboards in the past, but we also found it to be quite useful to have a tenant quota dashboard, which tells your tenant how much of the storage quota they've already used up. And again, because of our good index naming, we can just use the cat indices API and use this to collect all the indices that were created by one tenant, because the tenant name is literally specified within our index name. Now, how do we automate most of this? So the first logical prerequisite is that the tenant is fully onboarded in Kubernetes. Then, once this is done, our automation receives an OpenSearch sync data. Out of this OpenSearch sync data, we extract all the information and create a role mapping, and the tenant accordingly. Afterwards, automation loads some default dashboards for the newly created tenant, and the setup finish boolean is set to true. This in turn triggers the log flow, and log ingestion will happen, and tenants can access their logs. Now, what are the limitations of this? So first of all, the alerting plugin itself doesn't fully support multi-tenancy. So there's the risk that one tenant can see or modify the alerts that were created by another tenant, and you might expose things like emails and webhooks across all tenants. There is a partial solution to this. We could, for example, limit the access by the backend role in the configuration. But again, this is only a partial solution and not full multi-tenancy. When it comes to log parsing, Logstash itself isn't tenant aware. So every custom log format must be implemented through a dedicated pipeline. This can also not be offloaded to tenants themselves because there are no UI-based configuration tools and there's no self-service for it. This means that every change goes through the manual steps of ticket creation, development, validation, and deployment. So this is just additional overhead for us. A partial solution is this modular pipeline architecture that I've shown you before. Now, when it comes to quality of service, OpenSearch doesn't support native ingest limits or tenant-level quotas, which means you'll get your classical noisy neighbor problem that one tenant can negatively impact all the other tenants. So really, you're reliant to external monitoring and alerting to track those quality of service-related metrics. What have we learned throughout our journey? Well, when you're handling customer requests, it's really important to formalize a standardized process. We want a clear and repeatable structure and avoid any back and forth, delays, or miscommunication. So what has worked really well for us and might work well for you too is to use an IT service management tool to handle those customer tickets. Try to offer a clear and simple entry point so users know where to reach you, and also provide guidance by using predefined templates to collect all the required information up front. So you'll need to know what tenant are you talking to, what OpenSearch cluster is the tenant referring to, and what type of request does the tenant want you to do. We also find it to be quite useful to establish a common communication channel for change and incident announcements, so tenants know where to look first when something goes wrong. So obviously, when you're operating a multi-tenant logging platform, effective monitoring is critical. So we want to catch the issue before users notice, and we also really want to avoid silent failures where all of a sudden everything stops working and nobody knows why. So really, our goal is to decrease the time to detect. For this purpose, we are using standard dashboards like Grafana combined with Prometheus and OpenSearch. But we also encourage you to be creative and think about your own metrics that you could track. For example, we found it very nice to keep track of the ingestion lag, especially if you're working with Logstash, to detect some pipeline bottlenecks. And also we found it quite useful to keep track of the node count, just to verify that the expected number of nodes is actually up and running. So now we're nearly done, and this is the last slide, I promise. We just brought a little gift for you guys. And essentially, this is HTOP for OpenSearch. And you can define a configuration with all of your clusters. And once you select a cluster in this terminal dashboard, you will see some information regarding your cluster health. You will see some node information, some recent snapshots that were taken. And you can see some active indices. So yeah, here's the GitHub link. Feel free to check it out and give us feedback or even contribute if you want to. Thank you very much, guys.
All right, so thanks for the presentation. Two quick questions. One, what do you use to automate the creation of objects like index templates, roles, role mappings, etc., etc.? Is it a Python script, or how is it automatically?
Heavily on. It's working. We rely heavily on Ansible. So we implemented most of our automation in tenant-specific Ansible playbooks, because the Ansible structure per se doesn't allow us to do all tenant-specific configurations that we need to. So Ansible is really, really mighty when it comes to variable settings per inventory and this kind of stuff, and group variables and so on. But if you deal with something like Logstash configuration, then multiple Logstash configurations per tenant and tenant-specific configurations, then you come to the limit with Ansible. So you need something, some intelligence around Ansible to implement that.
And why haven't you used data streams for the data? Because I saw you used a lot of attributes for your index names.
Mm-hmm.
Let's repeat, so it will be on the recording.
Thanks. So yeah, I saw you used a lot of attributes, which makes sense, tenant, et cetera, but you used indexes so that you rotate them weekly or monthly or whatever. But why haven't you considered using data streams instead?
Actually, we didn't have considered yet. It's a legacy issue.
Okay.
So we started with that. We had the automation for the index naming. So we have some use cases where we use data streams, but for this particular cluster, we use the index naming.
Okay.
Yeah.
Thanks.
Other questions? One more question here.
Thank you for the presentation. So I saw that you're using login operator, and then you're sending logs to Logstash for the parsing. Are you doing any parsing of logs with login operator? Because flow, like with the flow, like you can do some regex parsing, sorry, and stuff like that. So I wonder if you just rely on Logstash completely, or if you're doing anything with login operator on that end.
Maybe I can answer this question.
Yeah, 1 minute. I'll just give you microphone because we want to have nice recording.
I'll just go back to it. Yeah, so we also do some parsing here, but not very much. It's mostly just appending additional data and leaving the rest for Logstash to do. I think there is also some parsing happening here in the ingress controller, but it's just regex based to filter out the logs that we are not interested in. So it's not like we are actually transforming every single event. We're just appending stuff to it, but we're not parsing in the sense you would be parsing with Logstash, for example.
No more questions. So thank you very much again for your presentation.
Thank you.
If somebody wants to ask personally, they can just come and ask. So that's all. Yep.
Yeah. Thank you.